So for section 3.4, we're going to talk about marginal functions. And marginal functions really, they're used a lot in economics. And they're talking about how rate of change are with different economic quantities. So this section actually has a lot in here. I just picked a couple of topics so that when you see them in maybe an economics class that they'll be familiar to you. So the first thing I want to do is look at a cost function. So this is a cost function for the number of washing machines that were being made by a particular company. So the equation is given to us as 7,000 plus 300x minus 0.1 x squared. So the first thing I want to know is what's the actual cost of making the 251st washing machine. So in order to find that, I need to find the difference between making the 251st and the 250. If I don't do that, it looks like the cost function is telling me how many to make 251, but I just want to know the 251st is the only one that we're interested in. So what I need to do is do C of 251 minus the cost for those first 250. I want to subtract that out. So back into our equation, I would just get 7,000 plus 300 times 251 minus 0.1 times 251 squared. So that's C of 251, and then I have to do the same thing when I plug in 250. So I get 7,000 plus 300 times 250 minus 0.1 times 250 squared. Oops, ran out of paper there. Alright, so when you evaluate these, you get 75,999.90 for the first, and then 75,750 for the second. Subtract those, and 249.90. So that's the cost of making the 251st washing machine. Next, I want to know the rate of change. So anytime I'm talking about the rate of change, I really want to know what the derivative is. So I want to know what is the rate of change and then evaluate it at 250. So I need C prime of x. So C of x was 7,000 plus 300x minus 0.1 x squared. When you take the derivative of 7,000, it's just a whole number, a real number, it goes to 0. Derivative of 300x, I get 300. And then the minus 0.1 x squared, that 2 gets multiplied out front. So I end up with negative 0.2. And then the exponent becomes 1 because we have to subtract from there. So C prime of 250 is 300 minus 0.2 times 250. And that gives us 250. So if we compare the results from A and B, they're relatively similar. So we can see that the values are really close to each other. So we can use this rate of change so that we can estimate what the actual cost of making that 251st machine was, or 250, or whatever you want to evaluate it at. So this is a really close estimate for it, and it's a lot simpler after you take the derivative. The function is getting smaller, and they're so close that it's fine to use that estimate. All right, the next thing that's in this section is average cost. And C bar is how we say it. And the average cost is just going to be the cost function divided by how many units. So that's going to give me my average. So if I have a cost function of, sorry, my notes are scrolling over here. My cost function is C of X is given as 500 plus 20X. So if I want to find the average cost, or that C bar of X, I'm just going to take the 500 plus 20X and divide it by X. And that'll give me 500 over X plus 20. Well, I want to know the marginal average cost as well. So to do that, I need to find C bar prime, because that's the derivative that I'm going to use. So remember, this X on the bottom is the same as 500X to the negative 1. So when you think of it that way, then that negative 1 comes out front, and it becomes to the negative 2 power, and derivative of 20 is just 0. So the average cost, the marginal average cost, is given to us by this equation, just negative 500 over X squared. Alright, so whenever we talked about cost, we talked about revenue and profit. So our revenue function, R of X, is just the price that we're charging times the number of units. Well, the price really depends on what the market is how it's behaving at the time. If you have a big demand for your item, you can sell it for more money, but you don't want to outprice yourself. So usually the profit is actually given by its own function, and again, it's based off of the supply and demand. So R of X is just going to equal the quantity you sell, X, times that function, that profit function. So if we had a retailer who's selling loudspeakers, and their price function is given by negative 0.02X plus 400, and the domain of that is between 0 and 2,000 that these numbers hold. I want to find the revenue function, and then I want to find the marginal revenue. So again, whenever you're talking about finding marginal revenue, profit, cost, it's just taking the derivative. So first we're going to find the revenue, and then find the marginal revenue, and then I want to evaluate that. At 2,000 units. So it's right at the edge of when this function holds. Alright, so 2,000 units. So first of all, the revenue is going to be R of X. It's going to be X, the number of units, times the price. And that price function was given as negative 0.02X plus 400. So I'm going to distribute that out, and we get negative 0.02X squared plus 400 times X. So that's our first piece. And then I want to know the marginal. So R prime of X is negative 0.04X plus 400. So here is my marginal revenue. And lastly, we wanted to know, evaluate that. So what happens when you sell 2,000 units? What's the marginal revenue? So negative 0.04 times 2,000 plus 400. And when you evaluate that, it comes out to be $320. So that's the marginal revenue that you're bringing in. Alright, I still want to work with this same data